appeared a few months ago. In continuum RG, so that appeared in this PRL and the longer version in this PRE, that it's even in a continuum one can see that, and we have now done a cubic lattice Monte Carlo simulation, which is to be published soon, which gives us this feature of FEM of DNA in three-dimensional cubic lattice. And what is important here is that this continuous scale invariance that I talked about at the melting point gets replaced by a discrete scale invariance. So if it means anything to you, I will be happy to talk more about it, but not in this lecture. What that means in a more conventional way is that instead of fixed points, the renormalization group shows a limit cycle. A limit cycle has a periodicity, and this periodicity gives a new scale in energy diagram. That's what gives us this tower, that's called FEM of tower, this infinite number of energy levels at this special point of potential. So let me summarize. So what we have shown is that this hypothesis of non-penetration of force, that gives us a model independent, that helps us in making predictions which are completely model independent about unzipping transition, and these things agree with various statistical mechanical models and simulations and so on. As I said, experiments still are not available. FEM of DNA is something very peculiar that you can predict because of this DNA-based pair interaction. There are 3 bound. You remove one, it's denatured DNA, and it's only because of pair interaction at the hydrogen bond scale. It's at a microscopic scale. The origin is microscopic, but the effect we are seeing on a big scale, that's called an emergent phenomenon. So FEM of physics is an emergent phenomena in this DNA problem. As in single polymer is well understood, so are solutions and melts of polymers, but surprises and new physics are in these few chain problems like this DNA. So the only take-home message is, all we are saying is give DNA a chance. DNA can simulate many of physics problems in a biological setup in a test tube. FEM of physics was predicted in nuclear physics. Nobody could do it in nuclear physics. People gave up. For 30 years, it was just lying as a strange theoretical prediction. And then now, people have started seeing it in cold atoms. After our paper of this DNA, now people are saying that you can see it in liquid helium, you can see FEM of effect in magnetism, you can see FEM of effect in superconducting transition too. So what we are saying is that this FEM of effect can be seen in a test tube at 70 degrees centigrade. Much easier to do than this cold atom experiment. Thank you.